Uh, Hello everyone. In the last lecture, we discussed about what is a BDD and what is a behavior-driven development. It's some of the key aspects. So now we will look into very important topic in the software development. That is a software development life cycle, which is nothing but the SDLC. Okay, let's deep dive into the concept. So in later stage we discuss about what is the STLC, which is nothing but the software testing life cycle. Okay, so first of all, software development life cycle stands. So SDLC stands for the software development life cycles, and it represents the process of planning, creating, testing, and the deploying an information system. So SDLC provides a structured approach to software development and ensure that the end product meets the specified requirement. The uh, the typical phases of the SDLC are like some of the phases that mentioned over here, but initially we would like to discuss about the SDLC. So like creating the entire software applications, whatever the process or high level process or the low level process needs. So that entire life cycle is nothing but the software development life cycle. And the software development life cycle consists of the following important things, which are first of all planning, second one is a feasible study, then the system design, implementation, testing, deployment, and the maintenance. Okay, from creating a software to deploy on the production, we require those high levels things. We will discuss those things in details. So first is the planning. So like planning consists of first of all defining what we are actually like building, what's the functionality, what are the objective of this functionality, then the what are the different types of sources we have or to deploy like within our application, then what should be the timeline, is it a short term on the long run to build the entire project or the application, or we will release the application well within the particular timelines. So that kind of a timeline and the budget of course of the project. So these phases also involves the identify the potential risk and the how to manage them. Okay, so planning consists of those important parameters like by which we can assess or we can get um, like how should our project is going to work in the short run as well as in the long run. The second point is a feasible study. So before adopting or before implementing any project, we need to do the feasible study whether the project will be feasible or not. So first of all, analyzing the project's feasibility from various perspective, for example, technical perspective, operational perspective, and the financial perspective. These 3 points are very very important anyhow. Which means technically whenever we are going to build an application, is it feasible to build at the end to end testing, or we can say from first to last, is it technically it will build appropriately or not. Then some kind of operations, which means whenever we build any software, then if it is related to like healthcare sector, if it is related to the e-commerce sector, if it is related to the financial sector, then with the help of the software that we are going to build, is it really worth to build, or is it really happening, or operations will be so smoother than that it will actually make a difference in our high level process within the domain that we are selecting. So that kind of operational feasibility that we need to check. Also we need to check the financials for building the projects. We whenever we require the financials like within the project, or the cost of the project is feasible or not. So that kind of a high level perspective we need to understand. The next one is the system design. So so creating an architecture and design for the system based on the requirement gathered. This includes both high level and detailed design. So whenever we discuss about the system design or applications of the system, we require a proper architecture. When the scalability of the project is going to increase, then the architecture is the one who will help to structure the entire the code base, as well as entire like integration tools and like integration, like integrating the technology. So it's very important to understand and expertise in manage the architecture of the project, as well as design how the system or the project will design and implement in a long run, so that we did not fall in a trap to the glitch, to reach the glitch level, or we can say to reduce the efficiency or the effectivity of the project. The next one is nothing but the implementation of the coding. So we can say it's a ground process where we actually implement the code based on what requirements we have. So writing the actual code based on the system design specifications. So this phases involves developer to build the software. Okay, so this is a ground like methodology where developer actually develop the code. So once the developer develop the code, it's very necessary to test the code as a user perspective. Then and then only we can understand that like whether that the code is feasible, the functionality is feasible, whether it will run in various aspect, in various scenarios or not. So that's the point comes into the testing domain. So verifying that the software functions as expected and is free from the defects or not. This involves various types of testing, such as unit testing, integration testing, system testing, acceptance testings. So the points mentioned over here, that is unit testing, integration testing, system testing, and the acceptance testings, are the very important points in the testing methodology. We'll discuss those things in later stage. But whenever we think about having software testing, then we need to go into or consider these points like on compulsory basis to test the application in all aspect. So the next point is deployment. So deployment is the one whenever we like have an applications or the code base, then we need to deploy it on the production, so that the end user is going to experience those things in real world situation. Okay, so releasing the software to the production environment where it will use end users. This phase may involve the installation, configurations, and the I'm so sorry, configurations and the training. And the next one is the maintenance. Whenever we get the user's response as a feedback, based on that we need to modify some of the structure within the applications, and that falls under the maintenance part. Okay, and it's very important, and that's how big companies or the big applications are come up with the every release, or we can say every like a build upgradation. So the point is maintenance, providing ongoing support and the updates to the software to fix the issues, improve the performance, and add new feature. This phase ensures that the software continuous meets the user needs over period of time. So if each phase builds on the like previous one, ensuring the systematic and organized approach of the software development. So this point is very important, that the existing point or the existing concept is based on the previous concept. So maintenance is based on the deployment, and it is based on the testing and implementation and system design. So it start from the first point, that is the planning. So when the planning is very top notch, then we can directly say that the like other points are very effective while performing or doing the software development. Now, the next point is the software testing lifecycle, which is nothing but the SDLC. So SDLC, we can say it's a subset, or it's a part of software development lifecycle. We can see over here the point first testing, which is nothing but the in which we are going to test the software. But this domain is a very big and very important. Until and unless software doesn't meet the specific requirement, tester or the test engineer does not allow this to move further in the development process. Because if we skip this testing phase, then we know that even if entire process or the SDLC is going to work in effective manner, but end user will experience a massive glitch or massive code issues or the functionality issues. And that's why we need to have a software test the software. And there are some of the methodologies, high level scenarios, that falls under the SDLC, that is a software testing life cycle. So it has its own life cycle, so we'll definitely discuss those things. So it is a series of phases that guides the process of testing software to ensure it meets the quality standards. The typically phases of the STLC are, so there are some of the phases which are very very important. First is a requirement analysis, test planning, test case design, test environment setup, test execution, defect reporting, and the test closure. So from getting the requirement, understand it, test it, writing the test cases, like actual test execution and the test closure. So these are the high level scenarios of the SDLC. So we'll discuss one by one. First is a requirement analysis, understanding and analyzing the testing requirements based on the projects. Like what we have, like initially as a test engineer, what we have to do, we have to understand the how functionality works, and we need to have a proper documentation, that is the documentation or functional requirement given by the client side, to understand those. And based on that we need to write the test cases and understand this functionality work in this manner, and we have to test in this way so that end user do not experience the issues. Okay, so that's nothing but the requirement analysis. The next point is a test planning. So develop a test plan that outlines the strategy, scope, resources, schedule, and activity for the testing. So in this concept, whenever we get the instance for the testing, and whenever the development has been complete, then we need to have a test plan where test cases are there, test strategies are there, test scope and the resources are there, by which we can actually test the application in various aspect, in various scenarios, with the help of the some of the strategy that we decided. We need to understand and apply the preconditions and the privilege, if any case we have, then all those things like fall under the test planning. So the next point is a test case design. So creating a detailed test case that outlines the conditions and input expected behavior. So initially we can consider it as whenever we perform any testing with the help of a client's documentation, and based on that we can write the test cases. And upon exploratory testing, if any issues were occur, then also we can opt for or ask for the functional requirement from the client side, and based on that we can again write the test cases, and those are very helpful for the next release. So that falls under the test case design. Whenever we got the documentation as a test plan or the test strategy or scope or any kind of document, so while like before executing the test before executing the test execution, so we need to create the detailed test case and the outline for the input and expected behavior of the testing. Okay, so test environment setup, so preparing the hardware, software, and network configurations necessary for testing. So for the software development point of view, we need to have an instance where development has been completed from the developer, and whenever we got that development site, based on the expected behavior test cases what we have, we need to test the software in all aspect, and we need to mark or write down or document whatever the test result we have with first run, second run, multiple runs if needed. So this falls under the test environment setup and the test execution. So running the test cases in the test environment to identify the defects. So it's very important, if we run the test, then we have to log the issues or the defects if we found within the instance. So logging any defects or the issues found during the testing, details about the problems and the steps to reproduce it. Okay, so defect reporting, so there are multiple defect management tools like a Jira, or we can say test trail. So there are multiple defect logging management tools are there. With the help of that, we can either create a tickets for the issues, and we log the issues over there. And with the help of that, developer understand that okay, whenever like whatever development we perform, there are some of the issues present over there. Okay. And then like last one is nothing but the test closure. So like finalizing the testing process, which involves evaluating the test cycle, generating the test reports, conducting the retrospective, and improve the future testing. Let's suppose at the first release, we write the test cases like from the document that we are getting. With the help of that, we perform, like we set up the environment, we test the particular instance, and upon testing we found the issues that we report over there. So test closure is nothing but the for every release, before that we need to evaluate or like execute those test cases for every cycle and for every possible instance that we have. Those the or the relevant code will push into the production. Before that, we need to perform a cycles, and within the cycle we need to perform different types of testing, like a regression testing, smoke testing within the cycles before every release. And we need to generate the reports, and based on the test outcomes we have, we can have a go no go call for whether it will deploy to production or not. And like these are the high level perspective for the test closure. Also, there is one point that is a retrospective, which means that whenever any test closure, we need to submit every time, which means we test the entire applications. And after that, like within a testing, like from first point requirement analysis to the test closure, uh, what are the steps that effectively use, and what are the lacunas we found within the process, that that all points we understand within the retrospective meetings. And within this meeting we finalize that in the next process we improve those things, we minimize those things, we vanish those things, so that the testing process will be effective in next couple of releases, and in every time. So that's nothing but the STLC, that is a software testing life cycle. So we can say that each phase helps to ensure that the software is thoroughly tested and meets the required quality standards before its release. So that's the overall explanation of the STLC and the SDLC, how software development lifecycle works and how software testing lifecycle works with their high level main points. So the first points are the in the SDLC are planning, feasible study, then system design, implementation, that is nothing but the coding, then after testing, deployment to the production, and maintenance in continuous manner. Whereas in STLC, that is the software testing lifecycle, first of all we understand the requirement, then we perform a test planning, then we write the test case, then we set up the environment, then we perform the test execution, and we perform the defect reporting in test, like defect management tool, and then we perform a test closure. Okay. So thank you so much. Bye bye.